Let's do an example where we find the volume, the lateral surface area, and the total surface area of a cone. To start, I just want to kind of get all of my formulas down because I think that that'll really help us see the relationships between them. So the area of the volume, sorry, that doesn't make any sense. The formula for the volume is 1/3 times base times height. The lateral area is pi times radius times the slant height. And the total surface area is equal to the lateral area plus the area of the base. Okay, so we've got some commonalities, at least between volume and surface area. They both need the area of the base. And with lateral area and surface area, obviously to find the total surface area, we need the lateral area. And even if we take this formula a step further, because we know that the area of our base, or at least we know the shape of our base is a circle, so then the area of the base is pi r squared, meaning that the volume is 1/3 times pi r squared times height. So even between volume and lateral area, they both use the radius. So now that we have all these formulas down, let's look at our cone and see what it gives us. It gives me the height right here, 20 centimeters. So this is the height. It gives me the slant height, which is 25 centimeters. That's this right here. But I don't know the radius. I do not know the radius. So let's find it, because obviously in order to solve for volume or for lateral area, and then even further for surface area, we need to know the radius. Fortunately, the height and the lateral area make a right triangle. Sorry, the height and the slant height make a right triangle with the radius. So r squared plus height squared, which is 20 squared, equals the slant height squared, which is 25 squared. Now we can solve this out, right? But maybe you notice that this is a 3, 4, 5 right triangle. So this is 4 times 5. This is 5 times 5, meaning my radius will be 3 times 5, or 15. If you want to verify that on your own, feel free to pause this video and just solve it using the Pythagorean theorem. Okay, now let's find the volume. We know the height, it's 20. We know the radius, it's 15. And so we've got what we need in order to solve for the volume. 1/3 times pi times r squared, which is 15 squared. 15 squared. Times the height, which is 20. Okay, so that equals 1/3 times pi times 225 times 20. And I guess we can crunch some numbers here. This is 1/3 times pi times 225 times 20 is 5,550. That's not right. That is 4,500. Okay. It's been a long day. And then 1/3 of that is 1,500. So 1,500 pi centimeters cubed is the volume. Nice. Pretty straightforward. And again, I just want us to kind of recognize, maybe for future use, that this right here, 225 times pi, that's the area of the base. Okay, the lateral area. The lateral area is pi RL. So that's pi times the radius, which is 15, times the slant height, which is 25. And that looks like it's, I like to think about this as 25 times 5. I know that's 125. And then 125 times 3 is 375 pi. Of course, you can use a calculator. It's just easier for me to do it in my head while I'm using the computer. And again, this is area, so that's centimeters squared, not centimeters cubed, because it's just the area. All right, now the surface area right here is the lateral area plus the base. So my lateral area was 375 pi, plus the area of my base was 225 pi. So that means that the surface area is equal to 600 pi centimeters squared. So as you can see, if you take it step by step, you get the information you need, and then you do less work overall.